Hi folks, my name is Rafael Tassinari Resende from Universidade Federal de Goiás, Brazil. I'd like to start this conversation saying thanks to Yaroslav for the invitation. Let's talk about Enviromics, deciphering the G-by-E interaction in forestry genetics. I'd like to give credits to this free photo from the internet. So, talking about the Enviromics terms, we have a landscape with a lot of information, biological or not. And by envirotyping techniques, we can achieve some environmental information from this area. A set of environmental markers, we will have the Envirom, and taking a single environmental marker, we will have the envirotypic polymorphisms assisting the breeding, and a single pixel we will have an envirotype. So we see this landscape, taking it into a geoprocess environment. We will have latitude, longitude information, and every pixel in the area. And if we implant experimental or even commercial stand, of course taking into account the genotypic identification. So taking a single plot, we can measure some trait from these trees, like diameter or height or volume or some disease information, I don't know. When we talking about phenomics, this is a large high throughput kind of data collection, but here we're talking about environmental high throughput data collection. And we can collect this information by satellites or weather stations, or not so commonly, but by drones. Collect information by temperature, rain or frost and landscape elevation, altitudes. I don't know. There's many kinds of environmental covariables we can collect. Some variables not so variable, and others most variables. But of course, this is a single environment. When we talking about G-by-E interactions, we have to account a lot of experiments or trials or different kind of environmental information. So in this scenario, it is important to tell you about the target population of environment, wherein I mean that is the places where the breeding are done, or the places that the population you use the breeding products in a market scale. Here we have overlapped many kinds of environmental markers overlapped. This figure depicts the type of data that every environmic analysis will need. So we have pixels with data information, phenotype, genotype, environmental, and here a method of us showing how to transform environmental variables in environmental markers that can be used to this purpose. So here fast result, part A, B, C. So the first is the breeding zones, or also called as macro environments. I mean, here is a area that minimizes the G by E interaction defects. I mean, a single genotype planted here, you will have a similar behavior here or here or here, and so for this zone and so for this zone. This is maybe the most important result for an Enviromics application, that is the recommendation map, genotype recommendation map, wherein these pixels, each one of these pixels have a genotype key rank. So if you are here, you can take a GPS and read the latitudes and longitudes coordinates and know what the genotypes is the best for your condition or your farm, and go on. A genotype that's the best here could be not the best at the neighbor, but be the best in the another region, and go on. Here is a bonus result that is predicted trait prediction for the entire area. Here is an example like yield or volume. Here is a practical result that is we studied eucalyptus clones using volume growth or wood increment across ages, and so taking an early age or a so-so age. For example, here we can explore charcoal or firewoods. So for these products, aiming these products, we planting in exactly this configuration. See the colors at genotypes clones. And for pulp or cellulose purpose, we can planting the genotypes in this configuration, wherein these areas are geoprocessing areas with latitude, longitude, and etc. Here is genetic parameters like irritabilities. Irritabilities or genetic correlation are not calculated to a single environment or a set of environments, but for the entire area. And this is very interesting because could provide us some results that we cannot imagine it to have, because we will never test it in the fields where there is not phenotypic information. This result is very interesting because we have not to be afraid or not worry about imbalancing on genotypes. For example, here we have the reduction of the number of experiments, and here we have the reduction or the genotypic balance. The reduction of experiments is very dangerous on the prediction or and the reduction of balancing, I mean use the same number of experiments or fields, but with the less number of genotypes. The modeling fix this problem, like mixed models of Bayesian models solve these problems easily. Coming the finish of our presentation, we can conclude that Enviromics is a omics. I mean, not 1, 2, or 50 experiments are the target, but all the area. We always must try to use all environmental information or climatic or landscape or even management practice, for example, escape of some diseases or planting spaces in the rows or inter rows in the stands, and go on. We can use all data types, like for example molecular markers to address the relationships between genotypes. Enviromics is something like about precision forest, wherein the genotype is the management treatments, and we can easily calculate genetic parameters for the entire area into a Enviromics quantitative genetics framework. I'd like to again to thank you very much, and I apologize for my non-native English. So here is my contact, my email address. Thank you very much.